Yeah. You go for a walk and then when you come back it doesn't compile anymore. Yeah, bloody vector. I'm slightly confused though, because I think that everything worked before I started working on this thread safety stuff. What the hell? Wi-Fi? What do you mean, Shy? Is this thing track graph data? Probably. I have an excellent connection, it says. You have a bad connection, Shy? I don't have that here. Why do I have a macro that is literally used once? With an if. Which means that the compiler should complain when it is not defined. And it doesn't define, it doesn't complain, so it's not defined, but why? It is already so hot today. And then I have this. Completely beyond me how this works. It's only graph data. Suppose I deleted it. Class member test 211. Another way to check if I still have this, looking at DC tracked. Nope. Amazing, it compiles. Sometimes, very sometimes, something just goes right. And this is what I printed. E4. No, that's not why I'm here. I wanted to turn this on again. And then what happened? Oh, that's not what I wanted. Make hello world. And then what happens is deadlock. Oh yeah, deadlock or crash. Can I repeat this until it crashes? Apparently not. So let's run it. TTP hello world. So we have an uninitialized mutex. Does it mean that this mutex is uninitialized, which probably means that the m unlocked, whatever that is, points to something uninitialized. And it points to, well, that Do I have a debug output about that? No, I don't. That's annoying. Oh, prints all kinds of stuff except the this pointer. How useless is this output? What the hell? Why do I get all this debug output without any this pointer? Ha, ha. Okay, let's try the other way. Well, actually, no. Ugh. How can I print that name? How can I print this name? Let's track. I think it's just name. Brett, I do respond to chats, but with a delay when he goes out to look at it. Yeah, it is true. I'm trying to remember where this is being defined, for example, and then of course we find that immediately as being defined here. So kind of an IDE, right? But then using the full screen width instead of just a small drop-down thingy. So this is derived from I found it. It's derived from tracked with a name pointer. That is just a bloody name. The name that I'm looking for is like literally a template argument. Either that or tracked has it. I doubt that. No, name. No. It's just a pointer and the name is a template argument. It's a I can print it. That prints the name. Entry. No, it's something else. No, it's tracked. I think that does print the name. To print the name. Yep, just print the object. And then from the debugger, that's probably not going to work. I need a name thingy. Entry returns an entry. That can be printed and it just prints a name plus an ID. Aha! Oh, of course, I need to print the ID then. Well, that's the ID of the entry. No, I don't think I can print this from GDB, but let's try it. So theoretically, I could print standard cout right this unlocked, which is a pointer. So let's put a star in front of it. What the hell does it mean? Thread safe unlocked. Blah 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 isn't fully known to GDB. What? Try printing it like this. Tracked. So it's an unlocked dot item and so on. Okay, yeah, well, an unlocked node item, but then I definitely need the ID as well. The ID. How do I get that? See, I'm never going to get that. What the hell is this? Oh, yeah, okay. Unlocked is undefined. Is deleted. So I should see at least this somewhere being destroyed. Delete. So that could be one. No, look, I see 1, 2, 3. That's the size of my array. May I have more of those? Nevertheless, it is possible. No, it's not. Yeah, it is. Definitely, yeah. Here's a construction. Maybe I should just print when I start to create the array, then I know which elements are in it. But here's 7. And then 7 is destroyed here. It's like really, really destroyed. But in the meantime, I would expect also to see a copy constructor. And we don't have that, right? We don't have that. Nope, I'm creating here an unlocked, and those are just unlocked bases. And that's pretty funny. 8 is an unlocked, but it's not a copy constructor. Hello, Ishan Tiwari. I cannot hear you, no. I can see you. I can see you type. You said hello. Hello. I think I see what's going on. I'm creating a temporary here. And then we are storing it in the vector as an unlocked base. AKA as a base, as a pointer. That's bad. That's not what you want. So what is left over afterwards is 45. 7 is constructed, and then we construct a 44 from that probably. So this is pointing to 7, and then we construct a 45 from that with a copy constructor, who 44 is copied. So we are completely working with an unlocked base, which is then stored in my vector. But the thing is pointing to something, and that something is then destructed and deleted. Here's another copy. 50 is a copy of 45. Yep, and then we destruct stuff. So now all the base things are pointers to the unlocked things, and they are destroyed. But if afterwards only unlocked base objects are left, then why the hell is the thing that I'm trying to print here an unlocked? It's not an unlocked base. Was that the thing that I was pointing to, and then it gets, I don't know. Yeah, it's time to go up until we reach main. Just kidding. Table node.cxx, up, 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 up. Here's hello world. Woo, this is in right dot. Is that okay? Up, up, up. I think we're talking about the first one, table A. Here's table A, 145. And I need a vector, not a table. There it is, 132. So what I can do is set a breakpoint 134, run from the beginning, and now I can print v1. Base. Why the hell would that store a base? It's that, isn't it? No, not really. What the? Is it quiet? I don't get it. Oh. Oh. Yeah. Okay, so the item unlock type is an unlock base. It's a base class pointer, basically. That is being stored here. So this is a wrap around the base class pointer. And that's also the only member of const item pointer. And then the const item pointer is the base class of item pointer, which doesn't have members of its own. So it's still just a base class pointer, or derived from a class that has a member that is a wrapper around the base class pointer. And that is the base class of item pointer template. An item pointer template is node pointer, and node pointer is the base class of A. So at the moment we construct this A as a temporary before we copy it into the vector. The default constructor of node pointer is used, which is the default constructor of item pointer template node item, which constructs a new node item on the heap. For that, it uses a boost intrusive pointer to an unlocked type, which is actually past that pointer, where the unlocked type is the unlocked type of the template parameter unlock type. So that is a node item, and that has an unlocked. It's not an unlocked base, but an unlocked, which actually wraps the node item. So it is a node item plus a mutex pair, as it were. A node item plus a mutex pair is created on the heap here and then passed, passed to the constructor of an boost intrusive pointer, which will increment the reference count on that type. And it does have a reference count because the node item unlock type, which is an unlocked node item, is derived from T. So it's derived from node item. So the unlocked itself that we create on the heap is derived from node item. And node item is derived from item, dot item I guess, dot item, which is derived from AI ref count. That's my reference count. So that reference count is being incremented. At the moment we are constructing this item pointer template by this boost intrusive pointer. And the boost intrusive pointer itself is passed, dereferenced, so then we get a reference to the unlock type, which is passed to item pointer, the base class. But item pointer takes an unlocked type by value, and this unlock type is the unlock type that is defined in the const item pointer, which is the unlock type of item, which is an unlocked base. And if you construct an unlocked base from an unlocked, then you use this constructor here, and that just stores a pointer, base class pointer. So now my this thing here, which was the unlock type here, which was I lost track, damn it. This was this one. This unlock type here is now a pointer, a base class pointer, to the argument that was used to construct it. And that argument is an thread safe unlocked without the base. But it does not increment the reference count. Despite the comment. The comment says increment reference count of the item and become a pointer to it. So the idea, according to the comment here, is that we increment the reference count as long as this thing exists, and therefore keeping the boost intrusive pointer alive. I don't think the reference count is incremented, meaning that as soon as we return from this constructor here, the boost intrusive pointer is destructed, of course, just a temporary. Decrementing the reference count and deleting that unlock type, while we still have a pointer to it. This seems to be inconsistent with another comment that I wrote somewhere, which says that the original unlocked must be kept alive as long as you have an unlocked base. At least that's what I remember. While I said that, I also remember that later I changed that, maybe. I definitely changed that, right? I can refresh my memory probably by looking at that test. No, that's not the test. No, I don't know. None of them. Oh, that's a test in utils test suite. Not in this. So we have to look at util thread safe test suite. The unlock base test. Yeah, here you see, I explicitly tested. So I create an unlocked. Well, unlocked A here is an unlocked. And then we copy that. This is like literally the same. You see, you have the boost intrusive pointer, that's A, and then we dereference that and copy it by value into an unlocked base. That's exactly the same as happened in Well, actually it was at the top. So the base class of A node pointer is an item template. So we have here, we allocate something, put it into a boost intrusive pointer, dereference that, and then pass it to an unlocked base by value, as the argument by value is an unlocked base of the item pointer constructor. This one. This is an unlocked base. Maybe I should rename all the unlocked underscore types that are actually known base types. I don't know, probably wouldn't work. It would be nice. I mean, I know that this is a base type, so why am I not using that? And then I don't know. Anyway, though, yeah, right. So here, unlocked base constructed from a dereference boost intrusive pointer of an unlocked type. Same thing happens here. Allocate an unlocked, assign it to a boost intrusive pointer, dereference it, and then construct an unlocked B, which is an unlocked base from that. And then I reset here the boost intrusive pointer. Which should not cause destruction, because we still have this thing pointing to it. So what are we talking about? Is it or is it not destructed? Well, whatever is currently the case, clearly this has worked, and this is the intention. So the intention is that it should not be destructed. So constructing an unlocked B, aka an unlocked base, should increment the reference count. And I can check that. Okay, it stops the destruction because inhibit deletion should be called. It will be called if base is derived from AI ref count, and it is, right? So at least that's what I would hope. So the base here is yeah, well, of course it is. Base is this base here. This unlock type, which is unlock type from const item pointer, which is the unlock type from item, which is this one. So it is unlocked base of item. That's the dot item one. That is this one, and that is like directly derived from AI ref count. Therefore, the reference count should be incremented. Okay, so then I was wrong, well, because that in turn then means that if as soon as we return from this constructor, this thing is not deleted because it did increment the reference count. And should I not be able to check that then in the debugger? Now I changed something, let me recompile it. Nope, I didn't change anything. So go into the debugger again, run it till the deadlock. No, I mean not run to the deadlock. Is it a breakpoint somewhere? Where's my breakpoint? L minus. That's another up. Go up till vector A here. Okay, set a break with break 132. Run. Yes. Now set a breakpoint to 133. Now I do continue. Destructed. So it does get destructed. No, suppose I have no other option than to step into it and then just follow it. But following that for three elements at once is a bit much, so maybe maybe sneeze. Let's temporarily reduce the size of the array to 1. Utils vector. Is it me, or I type vector and I have to think about from? And I think that's because of Victor. But now I'm not sure if Victor is really called Victor or not. I mean, my subconscious apparently thinks he's called Victor, but is he called Victor? Because then when I consciously think about it, I can't remember the name of that guy. See, it's really a one-way problem, you know. Recalling memory that I have, it is in my memory, but I cannot recall it when I want to recall it. Really stupid. No, sorry, but now I want to know. What is the name of the guy? That's not working. Cast. Control F in case there is indeed a Victor. Peculiar calling out residents have been trapped in town since he was young. Yeah, so the name is Victor. I was right. Oh, my subconscious was right, rather. Okay, well, sorry about the interruption. It's a vector. I guess I can just do this. And then we have only 3 things, and that should work as well. GDB, hello world, run, no break, and now I don't know the line number anymore, of course. Or maybe I did. Utils a vector, and I'm going to step. Constructor of A. Step. Default constructor of item pointer templates. So this is now going to call new unlocked type. And that would be unlocked. Step constructor of unlocked and tracked. It's the base class of unlocked. I have no idea why we are now at the using, because that is a constructor. It's using the constructor of tracked. I have to do step, I'm afraid. And then we construct a node item. Why the hell? Did we somehow skip the constructor of tracked itself? Or was it just showing me of things that are coming? I think I have to look at the source code again. It's again the wrong thing. No, I have no idea what this is. Yeah, unlock type is a node item, right? We are creating an item pointer template with T as node item. As in, we are making an item pointer. No, we are not. Del. I'm constructing a node pointer. That is an item template, item pointer template of a node item. So this is node item. I'm doing new node item. Node item, yeah. Okay, so this is the first one because we need to construct it. And that is an item. Which gets a unique ID. And we construct an attribute list and primitive. That is the mutex. Oh right, no, it's not true. It was not a node item, it's an unlocked node item. So this is what we are allocating on the heap. And that thing, the unlocked, is derived from node item. So this is a base class of the unlocked. And then this is a base class of that, a base class of that. Attribute list is also somewhere hidden into it. And primitive is a part of the unlocked. So now we are back at constructing the unlocked, which calls us to construct a mutex. And now we are in unlocked base. So I would think that this is unlocked base. So this would be no, that doesn't make sense. That's not true. Where does the unlocked base? Where does the unlocked base come from? I mean, I didn't see. Maybe it's skipping intrusive pointer, the whole shit. And I'm already dereferencing or constructing the unlocked base. That is the argument of item pointer. That would be being passed the unlocked unlocked node item. So unlocked would be an it's an unlocked node item. So you just constructed that, and now we're passing that to the argument of item pointer. Okay, we'll go to item pointer. So trying to do this. We're unlock type. Unlock type is the unlock type of cons item pointer, which is this one. Unlock type of item. Dot item. Which is unlock base. This one, we are now constructing this, and therefore we have to call mutex. Good. So that's the mutex step. Primitive ref is constructed. I guess that is this one. The reference type is being constructed, and that is a base class of this unlocked base. To go through that constructor. Now we are 496 here, incrementing the initializing the reference, the reference count, debug reference count. So base should already be defined here at this point then. So print m base. It's item point. And that should be whatever we just allocated. It looks like it is allocated because it starts with a lot of 5s. And you also see here that a lot of 5s belong to the unlocked. Yeah, okay, whatever, base class. Step, inhibit deletion. Great, great, great. So I do get there, or not? I would say it is increased. Where's my ref count? This is ref count. vtable 4 unlocked. And then that's the start of AI ref count. What else is that closed? It's closed there. So this is really the count of AI ref count, and it's at 2. So for some reason we didn't get to see that. The inhibit deletion was not stepped into. I don't get that. But it is, yeah, it looks correct. It should have been 1 because of the boost intrusive pointer, and if we just inhibited it, aka incremented it, now it is the value is 2. And I don't want it to be deleted without me knowing, so let's say set a hardware watch point on it. Bit disappointed that it didn't step into inhibit deletion. That's really weird. What do I all skip? There's a lot of skips, but oh, utils is skipped. Oh, that's the reason. AI ref count is skipped, just when you want to look at it. Skipping tracked, I understand, but utils and AI ref count probably should not be skipped while I'm debugging this. How can you delete something that is being skipped? That unskip, delete skip entries. Delete or disable. Let me disable it. And then the entry we had, I want to see this. See if it now tells me that arguments must be numbers or dollar variables. Okay, I need a list. Skip function, no, nothing. Don't get it. What about disable? Delete, I mean. Same thing. Numbers. Tja. No, now we really know what happens. I guess it starts to count at 1. And the last 3 were 21, 22 and 23, and I think I want to enable 22, because that would be this one, tracked. So we do the 22, enable. No, I think we are happy. And I am here, step. Wait, do me up. this was in the constructor of the argument of item pointer. So I think we go to constructor of item pointer. Yes. And the unlocked type here is an unlocked base. Not clear, but I guess it is, because here's a base. Yeah, it just doesn't print the type. Can I print it like that? Now it prints that. Is not helping, but yeah, okay. On top of my head, const item pointer is an unlocked base. It's an unlocked base item. Yep. Okay, so we constructed an item, and if we do step, we go to the constructor of const item pointer, which takes const reference, where unlock type is still an unlock base. And then we cast the const away, and then we construct a shared item pointer from that, which is, and yes, we go into utils. Thread saves this. Well, that's what I meant. Constructor of unlocked base. So this is something wrapping an unlocked base, I think. Or is it an unlocked base? I forgot. That is an unlocked base. Difficult. So now I'm going to construct an unlocked base from an. Why the hell did I cast it then? Oh, because it takes a non-const reference. Otherwise we would not have been able to call this. Yeah, this just takes copies the pointer and should increment again the reference count, so from 2 to 3. Let's see if that happens. So we do step, call mutex, do the mutex stuff, tract, copy base, get base, actually copy it, do the mrf stuff, and we call again inhibit deletion, and mbase is not the same as the other one, as it was before. And inhibit deletion, now we go into it, yep. And we do next, and now mcount must be shown as 3. Perfect. Turn previous count, ignore it. That is the end of the constructor. Oh, what happens here? That's a destructor of unlocked base. That must be the destructor of the argument of item pointer. The temporary argument of the item pointer. In other words, I can check that. this pointer is this, and I do up, we don't really see anything here. No, okay. Let me just do a step, and now this makes an m count equal to 2 again. And that's the bottom of the destructor, and then you are suddenly constructing a vector. No, I guess we are done with constructing this thing. I didn't see a destructor yet for unlocked though, so, but well, that is only going to happen if the reference count reaches 0. The reference count is currently 2. But we didn't even create a vector yet, or what? No, we didn't. Okay, so we have a temporary now. Temporary floating here. I think the whole A is constructed, but it's a temporary. It cannot even print it. Nobody knows where it is. Now we're going to construct a V and then use initializer list to copy that over. At which point we should be calling a copy constructor, I think, of A. Could also be moved. Let's do a step, making the vector. Bang, A is destroyed. Please. What? Impossible. That is impossible, man. I mean, this is a temporary A, so it has to be destroyed, but well, it must first be copied into the vector. Yes, thank you very much. Was it already copied to my vector? Length 1. Silently copied to my vector. Yep, there it is. But that was very silent. Very silent. I don't think my reference count was incremented, was it? The reference count is now 2, and then now we're going to destroy the A, so the reference count is going to become 1. And then I don't know what else is living, but that's going to be destroyed as well, probably, and then everything is deleted because we reach 0, and we reach 0 because it wasn't incremented right here when we're copying to the vector. At least it looks like that. Why didn't I see the copy happy? Hey, look at it is back. IT Relux, yeah, no time. Maybe when I turn completely senile and I can't code myself anymore, then I'll do tutorials to give my life meaning. Okay, Luxit, you don't have to do this for me, man. I have no time to support OpenBSD. I used to want to support it for all Unix, but no. So do you need it on OpenBSD? Otherwise, personally, I really wouldn't care if it doesn't compile on OpenBSD. No, okay, well. It used to be supported-ish, but yeah. I haven't compiled it for 20 years or so on OpenBSD, so there might be some bit rot going on there. Well, I think it has a README even from a very, very old README, right? Yeah. README OpenBSD or something like that. Yeah, no, I have to check that. libcwd is open, so hey. FreeBSD, OpenBSD, and this one. Only the set library is supported. Oh. But yeah, maybe OpenBSD is terrible linker bugs to make the shared library unusable. So maybe they fixed that in the meantime. Okay, so when I was still in my youth, I give up on OpenBSD for now. So good luck. Good luck with that, looks it. I already gave up. So you probably even knew what this means. There's probably no reaction from the OpenBSD developers. You can guess what it means. Oops. Where are we? This one. And now I'm out of it. What was I doing? I was trying to get to embase, I think. Yeah. Embase is part of something. I really have no clue. Can I just print embase here or not? Thought so. Very annoying. I think the shared item pointer is printable. Yeah, and that has embase. Now we're getting somewhere. And why did I want to print embase? Oh, because if we dereference that, then we get something with a reference count, I think. Yep, there it is, mcount, which I can access directly, I think. So the reference count is currently already 1. Already 1. Yeah, this is also silently decremented. No, let's print the address of the thing. Why is that printing it like that? Standard atomic int. No, it's probably just an int, isn't it? So I can do, let's say I cast this to an int, and then we dereference it. That's just 1. Okay, so I can print this address, and then we can do watch the content of that address. But yeah, no, okay, destructing A. Item template is destructed. I mean, which A is being destructed? It's a temporary, but yeah, it's a temporary. So I have an A in my V, or in my this is temporary. So it's the stack address, and we do up. Here's my vector V, and then V1 has an element 0 whose address is on the heap. So whatever I'm destructing, it's not the element in the vector. But I have the feeling we're going to decrement the reference count. So then that element in my vector, for some reason, got there without incrementing the reference count. And without telling me what it was using. Move constructor, copy constructor. I'm gonna do step, allow deletion. Yeah, done. Dead. And we are dead. So you do step here, and then you do step, old value 1, new value 0, and destruct it. Seems to me that the problem is that my reference count wasn't incremented when the A was moved, I think, into the vector. That's it. So maybe, yeah, well, it shouldn't be, but at least it should detach itself from, so a moved element should detach itself from decrementing the reference count at the moment it is destructed. In other words, it should set embase to 0. Right? And it's clearly not doing that, I think. I think it was moved. Let's assume it was moved. I mean, yeah, it must have been moved. I think it was moved. I mean, let me look again here. Does it say have a copy? Does this thing have a copy constructor even? Unlock base. This is a weird thing. It's not a const reference. Does that mean that we have a copy constructor or we don't have a copy constructor? Let me think. Do I want to allow a copy constructor at all? Because these things take a non-const reference. These two. And this one. Which is private, by the way. Copy. If we copy this thing, then what happens? I have something, it's const, and I make a copy. I have no clue. Well, is this what the hell? I cannot even wrap my head around if I can make this a const reference or not. Yeah, I think that the reason that it is not a const reference is because that would not compile. Namely, if there was a const reference, then the call to pointer here would return a const pointer. And base is a non-const pointer. So this thing is just always non-const. You cannot have there's no const version of it. Unless base would be base itself would be a const type, of course. But that's not how it works. Yeah, I guess you could forcefully make this a const, but don't think I'm supporting that basically. So yeah, and then you cannot make a copy, because a copy in the sense that you really copy it from a const reference, because the result, the copy, then allows to access whatever the thing that was const is pointing to. It's kind of const cast then. So I do not want to allow that. Also not by accident. So I probably, maybe, I'm not sure if this thing has a compiler generated copy constructor or not even. I don't know when that exactly is disabled. Let's pretend that ChatGPT knows, because I'm too lazy to look it up. If I have a class that has this constructor, oops, I copied the wrong one. That's unlocked. I want this one. Thought that would be pretty damn bad then. I'm not convinced by the answer of ChatGPT, but well, I guess we have to be play it safe and disable it. Yeah, this is really wrong. I don't believe this. I think that this adding a delete counts as user defined, and if you define it, then the move constructor is also deleted. So if you delete this, then it will also stop generating the move constructor. Let's test it out though. Yep, not repository, page side, one box. Do all those stuffs. Let's include, as if I'm going to print anything. As if I'm needing a main. Well, maybe I do. Well, this compiles because the compiler did generate a move constructor automatically. And now we add a const reference, aka the copy constructor, delete. And then it says what? I can't. The default constructor is gone. Okay, sorry. I have to add that. But that if it deletes the default constructor, move constructor will not be there. Yeah, well, that's just wrong. I'm convinced already. I think also assignments, but whatever. Yes, you're correct. According to the standard, declaring a copy constructor or copy assignment operator or destructor as deleted or user provided will prevent the compiler from automatically generating a move constructor or move assignment operator. This is done because blah blah blah. So by adding delete, you disable not only default blah blah blah. Okay, that's like the first time I have a better new answer. In all other cases, it just kept saying the wrong thing. I'm also not convinced that the copy constructor was even existing because of this. And we can test that, I guess, by creating a function test, which calls the copy constructor. No, okay, it was not disabled. So explicitly deleted, then it should not compile. Yep, now it says as a deleted copy constructor. But does it even compile now? Oopsies. So I was using the copy constructor. Aha. Aha. Explicitly defaulted move constructor is implicitly deleted. And now I deleted the copy constructor. I need a move constructor. It's impossible to get that thing in my vector otherwise. So I can delete the copy constructor here because that just wouldn't be well defined. I mean, it's just really bad thing. Can't have it. But I do need a move constructor. So we're going to do a user-defined move constructor. And that then should compile, I think. Dang. Okay, this is painful, but probably this is the bug. Oh, explicitly defaulted move assignment operators implicitly deleted. Yep, we need to define a move assignment actually for the we need a move assignment as well. But where exactly is it using it? Warning: explicitly defaulted move assignment or is implicitly deleted. I say use the default, but it cannot use it. What? Huh? Okay. No move assignment operator console is implicitly deleted because field shared item pointer has a deleted move assignment operator. Yeah, okay. So it's maybe not using it, but I say that it has to define it, and it can no longer do that. Let me start with commenting this out and see if it's actually needing it. Yeah, well, by the looks of it, I thought that it was definitely needed. On the other hand, I'm trying to define a copy constructor here, which is definitely not possible because I totally disabled it here, didn't I? Yeah. So no, we can definitely not do this. For the same reason I can't do an assignment. Okay, let's try to not define that one as well and see what happens. Call to implicitly deleted copy constructor of node pointer. Ouch. I guess I need to introduce a non-const reference copy constructor. You can make a copy as long as the original is non-const. And then this would also work because this is also a non-const reference. Here we have an assignment. For the same reason, I can make a non-const assignment if this thing is non-const. But is it? Is it defined here? Yeah, also non-const. Well, it gives me good vibes, hope, I mean. That this is going to work. If we just add back whatever I will need here, but then as we did that like that, and this one too. Of course, then we can no longer use default. Just going to do an undefined reference for now. I'll implement it once it compiles. No viable overloaded the node candidate function, the implicit copy assignment operator not viable. No known conversion from node pointer, aka to the table element reference. That's a node pointer. What was stored in copied elements? That's a table element. I'm trying to assign to a table element. Shouldn't I just use this? I can construct a table element from a node pointer. Reference. Yeah, it's assignment, right? It is assignment. I can add an assignment, or I can also add a table element copy thing from a non-const reference. Now that probably should work, but might as well add an assignment for this function here. And a move assignment. These things kind of go together. I just always skip the assignment stuff, but okay. So that is then returning a reference operator, and then we have to do this in the body. I return to this pointer. Yep. No, the same thing for the move on. Table elements reference operator equals node pointer assign that with a move assignment. I think my assignment operators are missing like everywhere. And it's going to require a lot of editing. No viable overloaded the for something. Now the problem is that node pointer does not have a move assignment. Yeah, I just need that. We just need that. Can I do using or something? Using. Using item pointer. Is that working? It looks a bit weird. Item pointer. Like that. As well add the other one. Moving is always correct. Which then must exist. They don't, of course. I doubt this is working. Const item pointer. No, 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 no. This is so not working. Don't even know that if it is allowed to do using, but okay, we'll see. And then here we have one requirement. Okay, I have one of these, and we need an a move. Error expected semicolon after using declaration. Okay, we get all of them at once, or what? Yeah, apparently. Oh, that's nice. Non-void function. Non-matching function for call to construct add. Yep, we just lost the copy constructor of A. And where is that required? Oh, here, of course. Yeah, and that's why we want a move constructor for A. No copy. We are going to move. We don't have a move constructor. Why do we have not a move constructor? I am afraid. I'm just going to do using. No, I need. Sorry, that's nonsense. I need an explicit move. I'm afraid that the compiler should still have generated it, so probably we lost the move constructor of node pointer. But then how will we know unless we forcefully tell it to try what I want? So I guess this doesn't compile, but why? Didn't even change anything. Am I mistaken? We cannot construct something. We cannot construct an A. We cannot construct an A from an an A const reference. And why is that? Why are we even trying that? Is this just requiring a copy? Okay, so you want to pause. Why is it not using a move constructor? What a crazy thing is this? That's pretty damn annoying. Oh. Oh. Maybe it's my vector. Why isn't it? Let's try that in one box. To have just a normal vector, and I want to create a standard vector or A, and we want to fill that with a default constructed how did we do that? Like this. V2, because my A is accepting an int. This constructs an A, and then we make a vector of that. And this obviously compiles. Or not. Well, it did, but it didn't link. And now it says I used your copy constructor. Okay, so if we don't have a copy constructor, then it's of course not working. Forbids declaration of parameter with no type. Oops, I forgot to add an A. There's a lot of blah, 2 pages to end with you deleted it. Yeah, okay. So now I'm adding a move constructor. And then it still doesn't work. Still doesn't work once we use the copy constructor. Okay, I mean, I could first create the A's and then move them, no? But then you need a default constructor, so it'll be so nice to add a default constructor. I don't think it's going to make any difference, but theoretically it could do it now. Well, it doesn't. It still wants to use copy constructor. Yep, and then even worse, who cares that the temporary thing is const, you know? If I do this, why not? Pseudo copy constructor, but also that doesn't work. It really wants to use the const or the actual copy constructor. Hey, Brian is back. And yes, Douglas Adams. Ah, it does know. It does know. Brilliant. Yeah. Well, that was a pretty humorless answer. Yeah. Yeah, that is funny. When I started to say this, I was thinking, what? It doesn't know? Yeah, this does know. It did know. Yeah. I'll give a thumbs up. Get tired of this. Maybe I should take a long break. Which also coincide with eating dinner. Yeah, now that would have been humor. Yes, Lexit. That's exactly what it should have done. It should have said 42. Didn't even think of that. Yeah, I'm kind of stuck. I don't know what is the best thing to do here, or the correct thing to do is. On one hand, I thought it was a good idea to disallow copy constructing an unlocked base, but that gives a lot of pain. I mean, if the result is that I cannot store node pointers anymore in a vector, it's definitely not the objective of this project. That should be possible. So maybe I should just not care about the implicit constcast that happens as a result of that. Or implicit, I probably have to explicitly add a constcast. On the other hand, we could try the 3, because then apparently I am not trying to construct an A right there, but it's going to construct it differently. But that's what ChatGPT said. Why do I not believe this? Plus no. Is that even true? It's still trying to use copy constructor. Yeah, what to do. I'm contemplating if maybe unlock base should always be a const pointer. Nah. Let's see, make an A, create a node pointer. Creation of a node pointer. Make copies. Yeah, we can make copies. Move them. Originals never change, is it? Yeah, it's super difficult. That's what it is. I'm getting the feeling that maybe I really need an unlocked base that is const. I'm doing that a lot already here, like for example, I have an access here and an access which is derived from access const, which in turn is derived from, const access is derived from access const and access as well. That is different than I was thinking about. Or is this also here? Nope. Well, this is a better example, I think. Write access derived from read access, meaning that if a function takes a read access, then you can pass a write access, because a write access is a read access. And a read access is derived from a const read access. Meaning that if you have a write access or a read access and a function takes a const read access, then you can also pass it to the const read access. It just gets more and more const. And it seems that this type is missing from my unlocked base. I should have a const unlocked base, I think. It gets more and more complicated, doesn't it? Now we have this, and now I want to make it derived from a const unlocked base, or maybe I should call it unlocked base const. Not the same convention as I used here. The const is in the front, but okay. And then and the usual trick is that the const version is actually the same as the non-const version, except that the API is such that you cannot change it. Let's have a look at const access, for example. Const read access here. It takes a const reference. And only returns a const pointer or a const reference. So whatever you get from it, you cannot change it. This thing is not allowed to be copied though. But yeah, as you can see here, it has a non-const pointer. But you cannot access that. You cannot access it as a non-const pointer. It just is a non-const pointer. Therefore, I need a const cast here to get rid of the constness that you take. Because we store it as a non-const pointer, but the const cast is okay because you cannot access the non-const pointer anyway. That is, if you use the non-const pointer to call PTR, then you do get a non-const pointer back, but we return a const pointer. So this const really adds const, and that's why you cannot change whatever you get back. While this would, you could change whatever this returns. If you remove the const here, it still compiles, but yeah, then it wouldn't be a const read access. And then the derived type, the read access here, which is derived from const read access, has protected access to the non-const pointer. So this can just be whatever it wants to do, and it also no, it doesn't. The right one does it. The difference between const read access and read access is actually just that you can convert read access to write access, but not a const read access. Yeah, so this one returns and the non-const pointer and the non-const reference from basically the same thing as above, but just the consts are not here. I think you can do this same kind of thing for the unlock base. Yeah, but follow that line, and I need something that compiles. I think I need to undo a lot of stuff that I just made, the changes that I made, and then introduce this, and then I'm not sure. Then it should magically work, I think. Magically. I don't think, I'm not sure I can do this without compiling. I need to compile errors to tell me what I'm doing wrong. Indentation. Currently we do not compile because Cheer. Looks at well, only small functions. If the constructors doing doesn't have anything else than an initializer list, and you can inline it. If it compiles, that is. It's possible that the header isn't able to get all the defines that it needs. Okay, I have to look at my Tesla stocks. Gee. I did buy more gold. Whoa, what the fuck, dip? Ridiculous. Really weird things happen on the stock market sometimes. I programmed in that I wanted to buy more gold at, well, this stock anyway, what is it, an ETC, at 57.6. Normally it goes up a few hundreds, and I did buy it at 57.6 because suddenly there was a huge spike downwards to 57.46. So that is like a quarter. It's like 0.5% down. Why? Why would gold suddenly be 0.5% down in half an hour time? And then it went up again. So that's just a spike down and then it went up again. So I did buy it, but I wish I programmed in, 57.5 or something like that. No, it doesn't really matter. It's still not much difference. Anyway, that so I made 34 euros already on that gold. But it could have been 100 euro. Wait a minute. I wanted to look at Tesla, right? Tesla. Tesla is on the rise non-stop, and then the other one is going down. So I lost 100 euros today on trade desk. Tesla is going up, as expected. Whoa, they have been back to 240. Holy shit. And then it went down. Why? Yeah, well, okay. What else shall we do with today, people? I don't want to code anymore. I'm gonna play a game. I should eat, but I'm so lazy. I don't want to get up and make dinner. Therefore, we will play a game of chess. So I don't have to get up and make dinner yet. Yeah, I'm out of theory here. Sort of. Where is this knight supposed to go? I could go here, stopping that. Stopping that from what? The castles, they put a queen there. What is he gonna do? My queen must go. But, what if the knight comes here? Just have to play this. I can play this right now. Or maybe not. Let's just begin with castle. We have to castle anyway. I have to push this pawn. That's the whole idea, of course. I push, he takes. Ooh. 1, 2, 1, 2, 3. I can push. 1, 2, 3. So like this, and then he must take. I take. The rook comes behind it, and then I just take something. There or there. I think pushing is possible. Why would they not push if it is possible? I guess I take back with a knight because then I can play this pawn up to defend that pawn. Okay, suppose you go here and the rook comes behind it, there's no problem, right? I can just go put my knight away. It did not take with the pawn. It did not take with the pawn. Oh yeah, that forces me to take again after having to. I take, he takes, I take with the queen. And I lose my bishop pair? No, I don't. Just going to go here. I have to take back. And then I take with the queen, of course, otherwise I lose a piece. Yeah, now looks pretty equal. I can go behind it. Or I can give my bishop pair here. Then double these pawns and then even castle that side. I'm kind of have a pawn majority now on this side. So if I take here, if it always takes to the center, of course, and they can still make he can break. Can they break? Actually, they can't break, even with the pawn here. If I pawn move this one 2, there's no breaking anymore. The king is a bit close there. At least there's no breaking with the pawns. But they have the bishop pair. I don't like that much. Let's continue developing. It's not like the As soon as I play my knight, he cannot play the knight anymore. Unless I'm totally mistaken. Knight goes somewhere, I would take here. And then that's a pawn. Because if they move this pawn up, I would give mate. Oh, he's gonna double. Oh, I'm so scared. My rook is defended 3 times. Now I have to play my bishop. Double this pawn or not? I could double this pawn. The idea is then that I can break here, make a free pawn, and he can't. But it's this line, and the king is super close to that line, so it's not very interesting. I'd rather keep my bishop pair, I think. Let's just retreat. One, two, three, four. Oh, what is that? Oh, I have to take. And then we laugh. What is the bishop doing here? Nothing. Nothing whatsoever. I guess I just should play f5 and then, you know, this is my free pawn. That's where I have to play. And then my king can come closer to the center. Oh, wait a minute. That was not... That was why I played the king, to stop me from taking here. Oh no, well, this is a fork on this pawn and that, so I have to take it. I'm not willing to give away my pawns. Yeah, it's not super good for me, of course, because it's not super good. I would like to have my king here. No, you cannot. Can I go forward? How about going here and then there? Yeah, that's possible. I'm so running out of time. Yeah, and that idea is what? The bishop is back on the useless spot. It's not like I want to go forward to this pawn majority. No, if now I go here, I get check. That doesn't help much. How about I start pushing this pawn here? I think that works. Almost promotion. We are almost there. Okay, not really. Ah, shit. I go here and give check there. I should go here probably. It should have given check and take here and then collect my... I go here and give check there, and then I go here and give check there, and then I have to go there anyway. And this is not good. Plus I have no time left. Might as well go there immediately. No, also not really. Let's play a little faster. Oh shit. Yeah, yeah. Not good. I'm losing. Oh, I wanted to push my pawn. Oh no, that was a bad move. Well, there's no time in the left. Want to push pawn and then take and give check and take this one. Plus double attack on this one. Yeah, this is lost. Forget it. Okay. I had a plan, but I ran so long time. So this was my plan. Push this pawn. Let me see if what it would have become then. I wanted to play this. Computer takes. Oh, that's not even possible, you say? Oh, it's not, oh, this bloody thing runs. Take, push, yeah, and then I'm dead. Yeah, true. Plus 10 for white. And now I can do it? No, I can still not do it. No, it was lost already. No, I have to